In today's lesson, we're going to have a look at solving some simultaneous equations. To start with, let's talk about the word simultaneous. The word simultaneous refers to occurring at the same time, right? So this happens when more than one line share a single point. Like in this particular example, if you notice, the point -1, 1 is shared by both the lines y equals x plus 2 and y equals minus x. So in a scenario like that happens, what we call these two lines is these two lines have equations that are called simultaneous equations. Now in this particular chapter, we're going to have a look at solving simultaneous equations using three methods. We're going to look at graphing method, then we're going to look at substitution, and then elimination. Now we're going to go back to some basics here, right? When we sketch two lines, what are the different possible options, right? So when we sketch two lines, we might have a unique solution, as it was the case in that previous example. So when the lines intersect each other at exactly one point, we call the lines to have a unique solution. The second scenario is they could have no solution, right? The no solution scenario applies to lines that are parallel to each other. So the parallel lines are never going to intersect, which means they're going to have no solution. And the final scenario is they could have infinite number of solutions. So the scenario of infinite number of solutions takes place when two lines have the exact same equations, which means what could possibly happen is the two lines might sit right on top of one another. So just like in this particular scenario. So the two lines have an infinite number of solutions if they both have the exact same equations, which means they're going to be sitting on top of each other, giving us an infinite number of solutions. So let's go into our very first method of solving simultaneous equations, right? So we're going to solve simultaneous equations using graphing method in this particular lesson. So let's have a look at this question here. So we've been given two equations. The two equations given to us are x plus 2y equals 4, and we have the second equation is y equals 2x minus 3. Right? So what we're going to do when we say solve by graphing method is basically we're going to try and sketch these equations into the Cartesian plane and see where the two lines intersect. So let's start with the very first line. Right? In this case, I'm going to start with the line y equals 2x minus 3. The sole reason being this line is in the format of y equals mx plus c. Right? If I compare the two statements, what do I get here is the gradient of this line is equal to 2, and the line has a y-intercept of minus 3. Now going back to some basics of gradient. So the gradient here is 2. If I want to write it as a fraction, I can just simply write it as 2 over 1. What that gives me is the rise of the graph is 2, while the run of the graph is a positive 1. Right? So going back to sketching lines with the gradient intercept method, the first step is we always start by plotting the y-intercept. So in this case, the y-intercept is minus 3. We have a rise of 2, so we're going to go up by 2 positions, right? And the run is a positive 1, so we're going to go to the right by 1 position, which takes us to a second point, which is what coordinates 1 minus 1. Right, so now once we have 2 points, all we have to do is basically join them with a straight line. So that's what I'm going to do at the moment. So I've joined the lines with a straight line. Right, now I need to go ahead and sketch my second line. The second line has equation x plus 2y equals 4, right? Which is not in the format of y equals mx plus c. Now, which is where we're going to use our second method that we learned in the last chapter, right? So we talked about finding the x-intercept and finding the y-intercept of the line. Now, to find my x-intercept, right, I'm going to make the value for y equals 0. So if I substitute the value of y equals 0, I'm going to get x plus 2 times 0 equals Now I need to also find my y-intercept, right? The quickest way to find the y-intercept is by making x equals 0. So if I substitute the value for x as 0, I'm going to have 0 plus 2y equals 4, which means 2y equals 4, and that implies the value for y is equal to a positive 2. Right, now that I've worked out my x and y intercept, all I have to do is simply plot that onto the Cartesian plane. So I'm going to mark my x intercept at positive 4, and I'm going to mark my y intercept at a positive 2. Right, once we've done that, all we have to do then is basically join that with a straight line. So that's what I'm going to do now. Right, now that we've sketched both the lines, we can see that they're intersecting at one unique point. Right? And the point they're intersecting has coordinates x equals 2. That's the point they're intersecting, and they have a coordinate of x equals 2 and y equals 1. And that becomes the solution for the two simultaneous equations we have in this particular question. Right? So this line that we've sketched is y equals 2x minus 3, and the second line we've sketched as equation x plus 2y equals 4, and they both meet at one point, which means they have a unique solution. So the solution to this particular question is x equals 2 and y equals 1, and that becomes the solution to this particular question. Right? You can always check if your answer is correct by substituting back into the equation. So if I take the first equation, which is x plus 2y equals 4, right? X is 2, so 2 plus, and y is 1, so 2 times 1 is 2, so 2 plus 2 equals 4, which means my answer is correct. Right, let's have a look at one more example. Right, in this case, both the equations are not in the format of y equals mx plus c, right, which means we're going to go ahead and find the x-intercept and the y-intercept in each scenario. So let's start with x plus y equals 6, right, so to find my x-intercept, I make y equals 0, which solves the x-intercept as x equals 6, and my y-intercept we can find by making x 0, which is also y equals 6. Right? So again, I'm going to sketch the 2 points onto the Cartesian plane. So x equals 6, y equals 6. I'm going to join it at the end. The second equation, I'm going to have 2x plus 4y equals 20. Right? Again, I'm going to go ahead and find my intercepts. So 2x plus 4 times 0 is 0, which means 2x is equal to 20. Divide both sides by 2, that gives me x equals 10. And then we're going to have my y-intercept, which is an x is equal to 0. The y-intercept can be found by making x equals 0. So if I make x equals 0, I'm going to have 2 times 0, which is 0, leaving me with 4y equals 20. And we divide both sides by 4, gives us a y-intercept of 5. On the other side, we have an x-intercept of 10. Right. So what I've done here is obviously, as you notice, the Cartesian plane is only a 6 by 6. I've just extended my line so I can include my x-intercept of 10 in this particular scenario. Right. So if I want to sketch my first line, I'm going to mark my 2 points, x equals 6, y equals 6. Join them with a straight line. And then I sketch my second line by plotting the two x and y intercepts. x equals 10, so somewhere roughly there, and y equals 5. So I mark my second point, y equals 5. Then I'm going to join them with a straight line again. Right, again, as we notice, we see that the both lines intersect at one point with coordinates x equals 2 and y equals 4, which means the solution to these two simultaneous equations is x equals 2 and y equals 4. And that's the final answer to this particular question. And again, you can check it by substituting into the equations. If I substitute the values into the first equation, 2 plus 4 is equal to 6, which means my solution is correct. Right, the final part of this lesson is basically to sketch the simultaneous equations using our CAS calculator and then finding a solution graphically. Right, so what I want you to do now is I want you to first copy down the two equations, so y equals minus 2x plus 6 and 2y plus 3x is equal to 9 onto your books, and then I want you to go to your CAS calculators. Right, so we're going to start a new document and we're going to enter a graphing page. Right, the first equation is y equals minus 2x plus 6, right, which is already in the form of y equals mx plus c. So we don't have to do any changes to the input. So I'm just going to type in minus 2 times x plus 6 and enter. And that sketches the graph of my minus 2x plus 6. I'm just going to move this label to the side. Now for my second equation in this scenario is 2y plus 3x is equal to 9. Now, the way our calculator is at the moment, we can only enter equations of the form y equals 2x plus y equals mx plus c, in other words. So we need to go into menu. I'm going to go into graph entry. I'm going to go into equation template. Then we're going to go into equation templates for the line, and we have to select. So again, graph entry, then we go into equation template, line, then we're going to select the standard input, which is ax plus by equals c, which is what we need to sketch the second line. All right, so going back to the equation of the line, so the coefficient for x is 3, the coefficient for y is a positive 2, and the value for c is a positive 9. So that's what I'm going to put in there. So 3, 2, and a positive 9, and I'm going to press enter. Right, obviously, as I can see here, that both the lines intersecting at the same point. Now, in this particular scenario, we are able to find the coordinates just by looking at the graph. But in some cases, that might not be possible. So what we're going to do now is we're going to use a calculator to find the point of intersection. And the way we're going to do it is this way. So we're going to go into menu, then we're going to go into number 6, which is analyze graph, and then we're going to select intersection, which is number 4 there. So once you select intersection, right, your calculator is going to show you a lower bound on the screen, right? So from this point, what we just have to do is we just have to do one click on either side of the point, right, using your mouse pad that you have. So we're going to make one click, right? And as soon as you click once, the lower bound should change to upper bound. Then using a mouse pad, you move to the other side of the point and then you do a click again, right? And as soon as you do that, you would notice the coordinates of the point of intersection appear on the screen. So going back to the question, right, solving by graphing calculator, the point of intersection is 3, 0, which means the solution to these simultaneous equations is x equals 3 and y equals 0. All right. So again, if this question was in a multiple choice section, you're better off to use your calculator to find the answer much quicker than doing the working out. All right. So that leaves us with the questions that we need to complete. right? The questions that need to be completed are in the Check Plus Year 10 textbook. I'm going to attach the PDF of that chapter along with my email today. I want you to go into exercise 4.2, complete questions 1 to 4, in which I want you to just do one column each, and then questions 5 to 8 completely. Thank you for listening and